Hello everyone here, this is Eason from Think Academy Singapore. Today we are going to talk about divisibility. Divisibility is a way to find whether a multi-digit number is a multiple of a certain number such as 2, 9, 7 or 13. So for a certain multi-digit numbers, let's write maybe A, B, C, D, E here. How can we find if this number is a multiple of another number or not? So for some numbers, we classify it in three classes. The first one is a multiplier, a factor of the power of 10, which is 2 and 5. A multiplier, a factor of 10. 4 and 25. Factor of 100. And 8 and 125. Factor of 1000. For this three kind, we just look at the last digit of the multi-digit numbers. For 2 and 5, we just look at E. So if E is a multiple of 2 and 5, then the ABCD is as well. For 2 and 25, we look at DE, the last two digits. And for this, we look at last three digits with CDE. So this is the first type. We look at the last. The second type of numbers are factors of the power of 10 minus 1, such as 3 and 9. Factors of 10 minus 1 is 9. 11 and 99. A factor of 99, 100 minus 1. And 27 and 37, so which is a factor of 999, 1000 minus 1. So for these numbers, we can cut the multi-digit numbers by digits. For example, for 3 and 9, we cut 1 by 1 and add its sum. For 11 and 99, we cut 2 by 2, but to remember, just we cut it from the right to the left. So it's DC plus DE, BC, and A. And for 27 and 37, we cut it by 3. So CDE adds AB. So we find the sum. It's plus E here. So if the sum is a multiple of this number, then original number is as well. So this is the second type. So to be specific, the 3 and 9 here can be cut any way you like. So you can use A plus B plus C plus D plus E. But if you like it, you can just use A, B, C, D, E or A, B, C, D, E. So anyway, any length you cut it will all be okay. The sum of it always share the same divisibility as the original numbers. So this is something we may mention. Then the third type is the factor of power of 10 plus 1. So maybe in a black color. Such as 11, 10 plus 1. 101, 100 plus 1. And 1001, which includes three very important factors, that is 7, 11, and 13. So for these numbers, we can cut the multi-digit numbers digit by digit, and now we found its difference. For 11, we cut it by 1. So we can have an E here from the right to the left, and the adjunct numbers should be 1 plus 1 minus. So start with E, we have E minus D plus C minus B. Then plus A. And for 101, we cut it by 2, so it's DE, then minus BC, then plus A. So the old sequence is plus, the even sequence is a minus. But if you find that it's too large to be minus, you can exchange it. So the old number to be minus, the even number to be plus, then that is okay. Then for 7, 11, and 13, we can cut it by 3. So we can just calculate CDE, then minus AB. So this is the very important divisibility that we have already learned before, right? So how can we use this characteristic to solve problems? In NMOS, there are two kinds of questions. The first kind of questions, there's just test us if we know the divisibility. So, for example, the 2021 questions is 3 point. Number 3 questions are with 3 point. So it gives us a number that is 6,063 digits. So 6AB, 6AB, and if it's a multiple of 77, so we should know the all possible 2-digit number of AB here, right? So how can we solve these problems? So we have to say that n is multiple of 77. 77 is a composite number. So we can just notice that 77 is 7 times 11. So this is a multiple of 7 and 11. But about 7 and 11, they share a same divisibility characteristics, that is cut by 3 and find its difference, right? So now this multi-digit number is, very typical as it's repeated by a 3-digit number 6AB. So maybe we should cut it off. When we cut it by 3, there's no doubt that each part is a 6AB. So we have 6AB minus 6AB, 6AB minus 6AB. So the adjunct 2, we will find the difference is what? Is minus 20, right? But, as we can see, there is a odd digit. So we divide it by 3, it should be an odd number as well. So if you want to calculate it, it's just a 2021 here. So there are 2021 of 6AB. So when we cut it by 3, the odd, even. So there are odd groups. So there are 1 groups remaining here. So when we find the difference here, the later 2020 groups, will be calculated as 0 as they are minus to each other, plus minus will be 0, but there is 1 remaining. So the remaining 1 should be the final sum of difference, which means that if 77 is a factor of the original number, then 77 should be a factor of the 3-digit 6AB, right? So let's just find out. So how many multi-digit numbers with the 100-digit 6 is multiple of 77? 77 times 8. So which is 616. Then if it is at a 77 here, it can be 693. So now, by exterminated, we have 2 numbers that these 2 numbers are a multiple of 707, just between 600 and 700. And the AB we want to know is 16 here and 93 here. We want to find the sum of AB, then we just calculate 16 plus 97, so it will be 109. So the question is solved. Still, I should remember that from this question, there is thing we should notice that for a structure like this, if we write a 3-digit number twice to form such a ABC, as this number is ABC times 1001. So, of course, this structure is always a multiple of 7, 11, and 13, which can help you solve this problem easier. Now, this is the first type of question. The second type of questions is merging the number theory to the countings. So this question occurs twice in recent years. Once is in 2019, and then in last year, 2022. So let's look at the 2022 problems. So we should know how many 8-digit positive integers that only contain digits 0 and 4 and is a multiple of 75. So this time we should form a multiple of 75. So we should follow its divisibility characteristic. Now 75 is 25 times 3. So a multiple of 75 is a multiple of 25 and 7. If we say it separately, to be a multiple of 25, its last 2 digits must be a multiple of 25, which can be 00, 25, 50, and 75. In this case, however, we can only use the digit 0 and 4, so the last 2 digits can only be what? 00, right? So the last 2 digits is 00. Then for 3, we calculate the sum of its digits. So the sum of its digits must be a multiple of 3. Now we can see that 0 doesn't influence the sum of digits. So look at 4. So there are 8 digits. Last 2 of them is 0. Then we can see how many 4s are here that can form a multiple of 3. There are 2 conditions, that 3 4s or 6 4s, right? So by 25 we define the last 2 digits. By 3 we can define the number of 4 we can use. We can either use 3 or 6 4s. Then now we know these things, then we start to form the multi-digit numbers. We can discuss 2 different conditions. The first condition that we use 3 4s and then 5 zeros, right? Now, in this case, for this 8-digit number, we know that the last 2 digits of it is already 0. So we should define the place of 4 and place of 0 in the first 6 digits. To form a digit number, there are 2 types of questions. One is that every digit shares a different number, and the second is like this: we can use same number on different digits. And for this kind of questions, we can change our views just to decide which place to set this number 4 and 0. And when counting something, we know that what is special must be placed first. In this case, 0 is more special than 4, as 0 cannot be put at the top digit, right? So we can just choose the place for remaining 3 zeros. There are 1, 2, 3, 4, 5. These 5 places that can be written as 0. We choose 3 from it and to be 0. So this is choose 3 from 5, which will equal to 5 times 4 times 3 and divided by 3, 2, and 1. So the answer will be 10. So there are 10 ways to arrange the 3 zeros, and when 0 is set up, the remaining digits are all 4s. So these 10 different ways define the 10 different numbers. So there are 10 different numbers in this case. Then, for second situation, if we use 6 4s and no zeros, not zeros, 2 zeros, as the 0 should only be at the last. So the first 6 digits are all 4. So there is only 1 ways. When added together, 10 ways plus 1 ways. The answer is 11. So this is a question just asked us just not only to fit the divisibility, but to do a counting work. So this type of question is difficult, but I think you have the ability to solve it. Okay, that's all for today. Thank you and keep fighting.